Alrighty, so today is day number 1 of our new unit, probability. Probability is a fun unit because you get to start trying to figure out the likelihood of certain events happening. I know this is something that a lot of people I'm always curious about when they come into stats. What's the likeliness of this event or these two events happening at the same time, or this event first and this event second? And so in the next couple of weeks, we'll discuss all that stuff. I will say up front that probability at some point will probably mess with your brain a little bit because there's some things about probability that at first just don't make sense. So it'll take some practice and some understanding of how the events are going on. But it is a fun unit because, again, you get to use the calculator. There's not very much, if any, like writing and typing out stuff like we did the last unit with all the sampling and experimental design. So a lot of it's just straightforward, plug in your stuff and here's the answer. So if your brain is the one that likes to do like formulas and things happen a certain way all the time so that we can get the right answer, then you'll probably like this unit a little bit more than you like the last one with all the interpretations and the possibilities and the what if stuff. Please ask lots of questions with this, all right? Because even as I'm going through it, sometimes I don't, it's not clear, I guess, sometimes when the examples out because it does mess with you at first. So don't be shy. Ask for help. We can talk about different ways to look at it and help you guys kind of understand what's going on with probability. So in order to do that, we start off with, of course, the basics, counting principles. All right, so I'm at the very front of the notes, counting principles, permutations, and combinations. So if you took a geometry class before, which I think pretty much everybody has to, some of this will look a little familiar because there is some concepts from that course that do come into this play a little bit. But basically with counting principles, permutations, and combinations, we're trying to figure out how many different combinations of something we can get. Before we even start doing, Sebastian, if you want the outline here, before we even start doing what's the likelihood of something happening, we need to know the total possible ways that it can't happen. And that's the first thing that we are going to look at with this load. So if you look at the very first part of your notes, that's where I'm at. A counting problem asks the question, how many ways can some event occur? All right, so for the first example, just for us to look at so we can get our brain kind of around what we're talking about today, how many 3-letter combinations are there using the letters A, B, and C and D if there are no letters that can be repeated? So you have 4 letters to choose from, but you want to make combinations of 3. All right, one way is to list out all the possibilities. So I'm gonna let you guys experiment with that on your notes. You see that the first one there says ABC, ABD, ACB, etc. All right, keeps going, ACD, ADB, ADC. So play with that, take a few minutes and see if there are some other ways that you can make up combinations, and then you guys will probably start to see a pattern. Some of you guys faster than others, and that's good. On what the total number of ways we can make a 3-letter deal there with the, let me go ahead and find my camera. There we go, so you guys can see where we're at. Hopefully you guys had a good weekend. There we go. No, sir? Oh, yes, sir, okay. I was like, oh, Riley, sorry, man. A moment of silence for losing to an undefeated team. There we go. Oh wait, that was expected. Actually, they played better than expected. So everybody's all like, "Hey, maybe that quarterback's got something going there." I was like, well, he certainly looked better than Dalton losing his head and whatever the Danucci had there. All right, so here's where we're at on the notes. So again, try to fill out. I started with the A's for you: ABC, ABD, ACB, ACD, and then keep going. See if there's any more that you can fill out that I did not include on there. We want to answer the question, how many 3-letter codes are there? Because before we can even do probability, we need to know what the total is. Yeah, good old Danucci. Again, biggest hint I can give you guys with this section, if you try to, and I speak of this from experience, this is not me on my soapbox saying, see, I told you so. With probability, the more you practice, the easier it gets. I tried in college one time to watch this and went, oh, it made sense, and had to retake said course. So it's easy to watch somebody do probability. It's difficult to do yourself until you actually apply it and practice it. So every opportunity you get with these examples, I know some are probably not the most exciting, but practice them, try them out. You will be happy. Your future self will thank your current self. Unfortunately, this is not a unit where as a spectator, you're going to get a decent grade with it. Just ask some friendly advice up front. All right, so I wrote down what I thought would be the next column for B. You guys can help me out if you got something different, but we already had BAC and BAD. So following the pattern that we had before, I did B with the letter C next. That gave us A and then BCD, and then continued the pattern and put BDA and BDC. So far, is that what you guys have for this next column? All right, I'm gonna go ahead and do C while you guys are finishing up. Warm my brain up because I've been sleeping. Morning, girls. If you want the notes outlined up here for you, and if you need a calculator, they're right there. All right, so continuing with column C, I had CAB, CAD. Again, we're trying not to repeat letters. And then I had CBA, CBD, and CDA, and CDB. Is that what you guys got? I'm getting a thumbs up in class. Very good. All right, again, I'm just following some sort of pattern because I'm organized and it helps me out a little bit better than just randomly trying it. There we go. All right, and for the last one, I mixed the order on two of them, so messed me up. So the last one I had DAB, DAC, and then I had DBA, DBC, and then I had DCA and DCB. Yes? And they can be in a different order. That's just what I put on it. Let me zoom in a little bit because the people are squinting. All righty, so obviously one way to solve this question is to list it all out. This one wasn't too bad. There's only 24. What if I asked you to do 5-letter combinations out of the whole alphabet? Who wants to sit here all day? A, B, C, D, E, A, B, C, D. No, okay? Emily already shaking her head, no way. So there's gotta be a simpler way to do this, right? And we'll talk about that in a second. There's a formula that we can use to figure out these answers. All right, but just to get you guys thinking about what we're looking at, this is the idea behind probability. First, list out or understand what all your possibilities are. Then you can start to ask the question, what is the likelihood that some of these will happen or one of these will happen or whatever? All right, so we'll come back to this example in a second. If you haven't finished writing it down, then go ahead and finish writing down the last ones. Because when it comes to combinations and permutations in a minute, understanding the differences from this example makes life a little bit easier. All right, example 2, an experimental psychologist uses a sequence of 2 food rewards in an experiment regarding animal behavior. These 2 rewards are of 3 different varieties. How many different sequences of rewards are there if each variety can be used only once in a sequence? All right, so another way to solve these counting problems is to make a factor tree where the number of the branches is your final answer. So again, you may have done this before with a different class. I think geometry, they do some of this probability stuff as they go in there. All right, so what we're going to see is this example here. This is what I mean by a factor tree. So they are going to give 2 food rewards. All right, these 2 rewards are of 3 different varieties. So you start off, I got variety 1, variety 2, variety 3. So we're just going to call that A, B, and C. All right, so that's my 3 different varieties right here. And it says of these 3 different varieties, there are 2 rewards. Okay, so there's 2 here, there's 2 here, and there's 2 here. All right, so we've got B, C, and A, C, and A, and B. All right, so what you do is you count up the letters at the very end. How many unique branches do I have? 1, 2, 3, 4, 5, 6. So how many different ways can I do this? 6. So what is an easier method than actually drawing out a tree every time or counting all these things up? It's our friend multiplication. All right, so for this one, we had 3 times 2. That's what gave us the 6. All right, so count the number of branches to determine the number of ways. So there's nothing wrong with a factor tree. In fact, we're going to go back to those later when we start to do more probability and conditional probability and different kinds of percentages. They're actually very helpful. But again, would you want to do something where you have 10 and then like another 10 and then like another 10? No, you're going to be drawing a tree forever. It's easier just to multiply them. All right, so in this case, 6 different ways to give the rewards, depending on which of the 3 varieties, and then 2 rewards for each of those afters. And the labels could be whatever. Okay, so I just picked letters A, B, and C and that stuff so you guys can see the difference. All right, so far, any questions with what we have done? I know it's Monday morning and our brains are still not turned on yet, but I asked just to be safe. The look Emily has is the look I expect all of us to have, just that. I'm going to go with what you're saying, Mr. G, because I don't know where this is going yet, but I'm not 100% sure I'm on board yet. And that's okay. Perfectly fine. All right, so let's talk about the fundamental counting principles. So suppose that a certain procedure can happen or be broken into successive ordered stages. So we use a bunch of letters in probability. So we have to be aware of what the different letters be. So the letter P kind of stands for the chance or probability of something's happened. So we call that our procedure. All right, our letter P. N is the different number of ways. We've seen that before with other things. And then it can have different stages, stage 1, stage 2, stage how many. All right, then the number of ways P can occur is, all right, R1 times R2 times Rn. You just keep going. Again, multiplication is going to be our friend. All right, so example number 2, using the fundamental counting principle. All right, we've already kind of talked about it. It's just straight up multiplication. All right, so again, using the fundamental counting principle, the first reward was one of 2 things, and it was one of 3 varieties, so it's 3 times 2. Make sense? And much easier than sitting there counting all the possible results. This is going to take practice, though. Okay, you can watch this the first time, like, okay, I got it, and then it's going to kick your butt on something weird. So again, as we're going through these, make sure you are kind of practicing through these as much as we can. All right, so now that we understand kind of the idea behind the counting principle, and again, that's just using multiplication to find our final answer for things, let's talk about what is the difference between permutations and combinations. So we've used combinations before when we were using our sampling design. So that one should be kind of familiar, but permutations is a little bit different. So there's some fancy formulas, and then I'm going to show you guys that your calculator does these for you as well. So you don't have to actually memorize and do all these formulas. But there are formulas available for the counting principle because, you know, understanding what goes on behind the scenes and being able to do it by hand does help with the learning. So a permutation is where order matters. And I'm going to underline that on the notes because that is the important thing for permutations. Order matters. So when we go through our examples, we're going to have to decide if by changing the order of something, does that become a completely new answer or not? All right, the formula for a permutation is, all right, this is what we're going to see in the calculator, NPR, and I'll show you guys where that's at in just a second. So that's the calculator function, but it's the number factorial over the number minus how many you want in the group factorial. All right, so the N again stands for, if you go back and look at the notes, the N will stand for the number of different ways it can be broken into, how many different outcomes there are, that kind of situation. So if there's 24 ways to do it, then the N would be 24. R is how many you want per group. Okay, how many you selecting for your final outcome. And then you would use this one when order is important. So we go back to example 1 and we look at the fact that you have order is important. All right, so the little exclamation mark means factorial. Don't know if you guys have ever done anything with factorials before. Yes, no, maybe so. I don't know. We'll see as we're going along. If you haven't, basically what it means is when it's a 3 with that little excited exclamation mark, then it's 3 times 2 times 1. If it's a 20 there, then it's 20 times 19 times 18 times 17 times 16 times, and keeps going. So that's what that little excited little mark there means. All right. In statistics, it is possible for us to divide by 0 factorial, which is going to hurt your brain because every pre-cal, algebra 2, calculus, smart math person is going to tell you we never divide by 0, and they are correct. But 0 factorial equals 1. So we're not actually dividing by 0, we're dividing by 1. So just a reminder as we go through that. You go back to, you know, Ms. Dunstan or Ms. Hyder in your pre-cal class, if you had them before, you know, they harped on, we never divide by 0. They are correct. But we can divide by 0 factorial. This is why mathematicians and statisticians aren't always best buddies, because we do different math. All right, so revisiting example number 1. How many 3-letter codes are there using letters A, B, C, and D if no letter can be repeated? So in this case, order does matter. So if I go back and look at my examples here, we counted this one, A, B, D, and this one, A, D, B, and this one, B, A, D, and this one, B, D, A. And let's see, where's the other one at? D, A, B, and D, B, A. All 6 of those use the same 3 letters, but all 6 of them are in a different order. So therefore, in this case, it's a permutation because we counted that as 6 different results. Does that make sense? Whereas if order was not important, then we'll talk about this in a second. That's a combination. Then we would include all 6 of those as only one outcome. We don't care what order they're in. It's just those 3 letters. So the probability or the final number changes if we care about order making a difference or not. Obviously, there's lots of different repeats on there, but because we've flipped the order around, we're counting them as a different result. That is an example of a permutation. This is a little difficult to get your head around, so I'm gonna try to go slow for a minute, let you guys kind of absorb this in. All right, and permutations, the final order of my result makes a difference, therefore I count it as different. All right, so we would use that formula. Okay. So this is what we were going to type into our calculator or our formula. So the letter N is how many we have to choose from. So how many letters did we have to choose from in example 1? We had 4. How many did I want to be in each group? 3. So the N was 4. Oops, helps if I showed the actual formula there. So the N was 4 and the R is 3. I wanted 3 letters out of my possible 4 letters to choose from. So I put up a 4 here, so 4 factorial. And then this is 4 minus 3, which is 1 factorial. All right, so 4 times 3 times 2 times 1, that's 24. Divided by 1 times itself, which is 1. All right, so that's 1. So 24 divided by 1 gives me my answer 24. That's where that came from. Does that make sense? Now, we have a calculator function. This will save our life. I'm gonna make sure I remember where it is at because we want to do like 1,000 things in the calculator as the spring goes on. So it's in math, probability, there it is, okay. So here's your calculator. And if you don't have one exactly like mine, yours probably has something similar to this. So what I want to do is hit the math button. We're gonna spend some time in this area now because this is where all of our probability stuff. So it's the 3rd one down underneath the little second and alpha lock. If I hit math, it's gonna bring up this menu. all kinds of fun stuff on here. But go all the way over to the probability section because that's where we're at. And you will see our two formulas there. We haven't talked about NCR yet. That's the one we're going to talk about in a second. But number 2, you guys can see is NPR. You guys see okay in the classroom? I can zoom in if I need to. All right, so if I scroll down to here and I press enter, it's going to ask me to type in my two numbers. How many do you have to choose from and how many do you want per group? So it always goes first. And the R always goes second. So we had 4 and we had 3. I press enter, ta-da, yay, probability. I'm gonna get an actual answer. For a change, we're finally having an actual true answer. Now, if you have an older calculator like a TI, I wanna say like an 83, and it doesn't have all of the fancy stuff on ours, what you do instead is type in the number you want first. So if I have a TI 83, I still wanna choose 4, so I put a 4 in my calculator first. Then I'd hit the math button. Then I'd go over to probability, and you should still be able to find it there. Like it's still in the TI 83, it's just not as user friendly. So then I press my enter, and it's gonna automatically make that 4 my first number. Then I just type in a 3, and you should be able to do it that way. All right, that's for you guys with the TI 83. TI 83 is fine, worked great. You don't have to go get a new calculator. You'll still be able to do probability with this. You just have to be a little bit more old fashioned about how you type it in. All right, so that's a permutation. Order matters. And when I'm using the formula, I want to be able to say, how many do I have to choose from and how many do I want per group? So it's very important you identify the N and the R in your equation. Question so far. All right, like I said, this will take some practice because the hard part is not typing into the calculator and pressing enter. The hard part is deciding if it's a permutation or what we're going to talk about here in a second, if it's a combination. Because it will change the answer drastically if you use the wrong one. Okay. Nobody in class looks uber confused, so we'll continue. All right, so that was permutations. Combinations is where the order does not matter. So with combinations, no order. Does not matter. The formula looks more complicated, but what is happening? So puberty is fun, children. All right, so what is happening? I got so excited there. I'm gonna laugh myself for a second. Sorry, I'm easily amused. So what is happening with this formula is we are dividing or subtracting out the repeats because order doesn't matter here. Wasn't that exciting? I don't know why my voice went up by about 3 levels. All right, so my formula is NCR. At least you guys got to laugh this morning at Mr. G. This recording will not make it to Gambus. No, yeah, it should, so you guys can relax and realize Mr. G screwed. No, don't be sorry, man. Make fun of me. I don't care. If I was nervous about stupid stuff I was going to do in front of people, I wouldn't teach. All right, so for combinations, what's happening here is notice we've added an additional R factorial here. What we're doing is we're taking out repeats. Okay, because order doesn't matter. So if I go back and I look up at this one, at my examples, remember number 1, we counted these as a permutation as 6 different unique results. But with a combination, they're all one. It's all the same answer. So this one, this one, this one, this one, this one, this one would be one outcome versus 6 different outcomes. Because it doesn't matter what order the letters are in. I'm using the same 3. That's it. That's my final result. So that's where combinations and permutations differ. And if you're not careful, you're going to get a completely different result. So we basically ask you the same question down here that we did for example 1. How many committees of 3 can be selected from 4 people? And note on this one, the order does not matter. So it doesn't matter if Cole gets picked first, second, third. As long as he's in the committee, he's in. He's in the inner circle. Okay, so we're going to say we got 4 to choose from. I always write my numbers too big. We want 3 in the group. Okay, so this would be 4 factorial over 3 factorial times 4 minus 1 is going to be 1 factorial. And that's where we're going to get our answer here in a second. All right. Ta-da! There it is right there. So what's our answer this time? 4. And if you look, 4 is a significantly different outcome than 24. So which one is correct? They both are correct. It depends on what you want. If repeats are allowed or order doesn't matter, you're going to get different results. All right, so the first one, example 1, when we did it as a permutation, we had 6 unique combinations with the same 3 letters, but with a combination, All right, whether it's ABD or ADB or BAD or BDA or DAB or DBA, doesn't matter to me, it's all the same answer. So in this case, it's going to be a combination. So there's only 4 of them. All right, so let me stop, let you guys digest that for a second. Questions for me? Yeah, so Cole's got a good question. So basically, the main point of what you're looking for in the question is, does the order matter? That's got to be the question you answer. If you sit there and go, yeah, it does matter who gets picked for what or what spot they get or whatever, then yes, I'm going to do some permutation. If it doesn't matter, they're just in the group. Either way, everybody's happy. Then no, we can just do it as a combination. So we'll see some here in a few next examples. But some of the key things that tell you about like permutations are like if somebody finishes in a certain place, like first, second, third, right? It matters to Riley if he's in first place, second place, or third place. That's a completely different outcome to him. Okay? Or we're doing, different types of ways we can assign people to like official office positions, like president, vice president, secretary. Well, it matters if in the group I'm the president, or if in the group I'm just a secretary. It's a completely different job for me. So that would be a permutation. Whereas, hey, Mr. G's just picking 3 of us at random out of the class. Doesn't matter if he picks me first, second, or third, I'm going to be in the group anyways. There's nothing special about it other than I got to work with people. Then it's a combination. So order doesn't matter. So we're going to look at a few examples. And that's why I say with probability, you got to do some practicing. If you're just trying to be sitting on the sidelines going, oh, that makes sense, I got it, it's going to kick your butt. I promise. And that's, again, speaking from experience. I'm not trying to sit up here and be like, oh, well, do your homework. Like, I'm just trying to let you guys kind of know that's what happened to me. All right, so example number 4, how many ways can the 4 call letters of a radio station be arranged if the first letter must be a W and a K and no letters repeat? I already showed you guys how to do the thing in math, the calculator. The combinations one is right underneath it. So if you hit math, probability, and you go down to number 3, there's the combinations one. So if order matters, do number 2. If order doesn't matter, do number 3. If you want to do the official formula by hand, there's your little factorial symbol. Okay, so if Hope's like, well, I just like doing it by hand, then go for it. It's right there, right on it. Hope's like, no way, Mr. G. All right, the calculators are nice. So this is where you guys are going to appreciate these little babies. They do a lot of good stuff. All right. I'll let you guys take a minute, decide how many ways can the 4 call letters of a radio station be arranged if the first letter must be a W or K and no letters can repeat. So you'll have to ask yourself, does order matter of the letters or not? Take a minute, play with it, see what you get. And test your knowledge of the alphabet. And I'll try not to get too excited on this one. Remember growing up being embarrassed about that stuff. That's okay. It happens once a week. I'm waiting for my son to go through all that now. He's not getting no slack from his daddy. Toughen him up so the kids at school can't pick him. Well, if you want, on my desk is a copy of the best outline. If you're interested, if not.
You're not gonna believe this. I got here on time today, and then I got out of my car.
I'll believe it when you're here in time.
Walk into the building. I was like, oh no, I left my mask.
Ah, that's all right. Just see if you can sneak in. We'll see, Misha. We'll see. It's a good guess. I like it. Some people on Zoom are guessing what the answer would be. All right, so what we're doing is trying to figure out how many ways can the 4 call letters of a radio station be arranged if the first letter must be a W or a K and no letters repeat. So really the question that you guys would want to ask yourselves is, are those the same or different? Because then it completely changes your decision-making process. Did you make up those last 3? Yes. Yeah, this is an actual radio station that's been in Dallas for like decades. They're like a 500,000 watt. Like you can pick these guys up in California. That's why I picked them. I do not frequently listen to a particular radio station other than the ticket more often. Which would be KTCK, but then they have weird letters and it messes everybody's head up. All right, take about another minute. Again, learning to actually practice this stuff, make mistakes, see where your mistakes were made, try not to repeat them, et cetera, is going to make probability a much more successful unit for you than just watching Mr. G fill these up. I will tell you that it is a fairly large number. So if you got like 3, then you might want to go back and look. All right, so my final answer was 27,600. What did you guys get? Anybody get that? Close to it? No? Yes? Ah, yes, no letters repeat. So on this one, did I even have to do a C or a P thing? Not really. I could, but I don't really have to. All right, so well, that's what I was saying. You don't know until you practice. So let's go through the formula and how I got my numbers here. So how many letters are in the alphabet in general? 26. But I got a restriction here. So whenever I do probability, combinations, permutations, whatever, this is what Mr. G likes to do. I'm a very visual person. Okay, so if you guys are visual, this might help you out. If you're not visual, then sorry, you have to deal with it anyway. So I need 4 letters, yes? So there's my 4 blanks. So in the very first blank, I have a restriction. I got to have a W or a K as my first letters, yes? So that only gives me out of the alphabet 2. I have 2 possibilities. Depending on which one of those 2 I pick, I then have how many letters left in the alphabet after I pick either a W or a K. I have 25, right? Because 26 minus 1. So 25 go here. I've now picked a second letter, whatever it is I pick. How many do I now have left for the third one? 24. Continue this process. How much do I have left for the last one? 23. Now, anytime you're doing total answers, you multiply. I know, this unit's gonna make your brain go, oh. Sometimes in a good way, sometimes not so much. All right, you multiply all these up and you get a final answer of 27,600. I will tell you, we like to do license plates questions about this. We want to make a license plate. It has 7 spots. The first 3 have to be letters. The last 4 have to be numbers. Go. Or first one has to be this letter. The rest of them can be anything, et cetera, et cetera. So for people that may or may not be familiar with our total alphabet system, and I'm not saying that in like a rude or make fun of way, because I know English is a weird language. You might want to write this on here. There are 26 letters in our alphabet. And since we do everything pretty much based off of the English language in this class, that might come in helpful. And there are 10 digits in our number system. Okay, so if you look at your calculator, I have 1 through 9, so that's 3 by 3, that's 9. And don't forget 0. So there's my 10 digits. Unique digits, if that makes sense. So you might want to keep a little note of this, because this comes up all the time where I ask you guys to make final combinations or answers with that as your restrictions. Okay, so that was example 4. Just trying to hurt your mind a little bit on a Monday. All right, let's do number 5. How many ways can a class of 25 students elect a president, vice president, and secretary if no student can hold more than one office? So again, first question to decide is order going to matter on this one? Yes or no? And then do your thing. See what you get. So if you want to know what this last thing was, this is the counting principle. I spelled that completely horrible. I did like principal in the school. Elizabeth sitting at home making fun of Mr. G's spelling. Rightfully so.
I am.
You should be. The only way I don't get in trouble with my better half, because she's an English professor, is she never gets to see what I teach. All right, so example number 5, how many ways can a class of 25 students elect a president, vice president, and secretary if no one can hold more than one office? So the first question we need to decide is, does order matter or not on this one? Emily says yes. All right, we got another couple people in here shaking their head yes, they are correct. So if order is important, then is it a permutation or combination? Permutation. All right, so again, if Riley gets picked for president, that's a different group than if he gets picked for vice president, or it's a different group if he gets picked for secretary. He will be doing 3 different things. So therefore, they are not the same group. Very good. So if it's a permutation, then we can use our fancy formula. 25, letter P, 3. So again, for those of you guys that missed it or were not here in the calculator, I want to use math probability option number 2. If you got the fancy calculator, you just press enter, type in 25 students, groups of 3. All right, again, it's a completely different answer than if we said order didn't matter. Significantly smaller. Why is this one smaller? All the repeats that were in here that we counted as unique answers, taken away. So there's really only 2,300 ways to do a group if Mr. G was just picking 3 students at random out of his class of 25. I can make that many unique groups with it. Now your mind's going to start hurting. You're like, I didn't know he could do those many combinations. Yes.
How did you decide that order matters?
Because for me, and this is just going to be something that as we practice, we get more comfortable with. Anytime you're electing for a position, a unique position, then it's guaranteed it's going to be a permutation. Because if you get selected in the group, Cole, as the president, that's a completely different, separate outcome than if you got selected in the group by random to be the vice president. You'd have a different job, right? Or at least in theory. I know our experience with vice presidents in this country is they don't do much, but say that they did, that would be a completely different role. Or if you got picked to be the secretary, you'd be doing something completely different than if you were the president. So even though I have the same 3 people in the group all 3 times, which position you have makes the outcome different for you. So that would be a permutation. Whereas if I'm just selecting a group of 3 students to work on a project together, and I'm not assigning any specific role, just you 3 got to get your crap done, then it doesn't matter if I pick you first or if I pick you second or if I pick you third, you're in the group. So order on that one's not going to have any bearing on the outcome. Yeah, does that make sense? So typically, and this is me throwing out, hints, anytime you're doing specific positions like electing a president, vice president, that type of question, it's going to be a permutation. Or, we're trying to decide which place they come in, first, second, or third. Okay, stuff that has a unique title or a label to it, order is going to matter. Good questions. All right, let's look at number 6. How many 5-card hands are possible from a standard deck of cards? Those of you guys that aren't familiar with the devil's artwork of cards, just kidding. There are 52 cards in the deck. I realized last year that a lot of students don't play cards, so I had to explain. 52 cards in the deck, 4 suits, 13 cards per suit. I do relate a lot of my probability back to gambling. Sorry, it's just fun. So again, your first question should be, does order matter on this one? If I get my ace first versus getting my ace fifth, does that going to change my hand? Maybe it does, maybe it doesn't. All right, see what you guys got on this one. So does order matter? No, right? Because you can just sort them yourself when you get them in your hand. So on this one, you're going to use the letter C. Still a lot, though. And this is the other thing about probability that's going to scare you. Your number is going to look really weird sometimes. You're like 56,300,000. What? That can't be right, because we never do answers like that in school. It's always nice 3-digit or less numbers that are all whole numbers. We explained to everybody very well that that's all math is. And decimals and big numbers don't exist. All right, so combination on this one, because if I get dealt the ace first or third or last or whatever, guess what I'm going to do? Just sort it to wherever I need to, and I'm still using it. So in this one, order doesn't matter. Just the 5 cards I have, that's what makes it unique. All right, let's try the next example, number 7. In how many ways can 9 horses place first, second, or third? So if you just listen to my hint, you should kind of know how to set this one up. All right, so on this one, order, is it important? Yeah, the horse coming in first is completely different than the horse when he comes in third. So we get to use our letter P. We have 9 horses to choose from. We want 3 in the group. Ta-da, 504 ways to place them. All right, because that, you know, whatever the names they have, or let's say secretariat, that's just the one off the top of my head. If he comes in first, different than if he comes in third. Completely different group. All right, last one to blow your mind before we're done for today. Suppose there are 15 girls and 18 boys in a class. How many ways can 2 girls and 2 boys be selected for a group project? We haven't done one like this before, so experiment, see what you get, and we'll talk about it. And I do not know why the one girl is like super excited there. She got like airtime. Last year, some of my students like, she's just so excited. I was like, oh, no. Maybe I told her that there's no homework for the rest of the year or something. This one's a little bit different than anything we've done. That's the only hint I'm going to give. Same idea, same concept, but you got to be innovative with it a little bit. All right, about 1 more minute. If you're still stuck, you will use our formula, but just a little different. All right, last hint before I put the answer up. Everything in probability is pretty much a product of multiplication, outside of a few exceptions. So if you added anything, you might want to multiply. All right, so for this one, you have to be a little tricky, and you have to actually treat it as 2 different things happening at the same time. Because you want to guarantee your final outcome has 2 girls, 2 boys. Make sense? So if you mix everything together, then you've lost the ability to do that if you don't do it the right way. So what we did is 2 separate combinations that you multiply together at the end. Right? However you wrote it, if you got something like this, then you did it fine. So the first one, the 15C2, represents me selecting 2 girls out of my total number that I have there. So I have 15 girls. I want 2 of them. Does order matter? No, I just need 2. So that group is going to be that group. All right. So if it's, you know, Elizabeth and Misha, or Misha and Elizabeth, the same group of 2. All right. Same thing for the boys. There's 18 of them. I want 2. So I've got 18 to pick from. I want 2. So if it's Cole and Riley or Riley and Cole, same group. Doesn't matter which order I pick them in. Now, what we want to do is multiply their separate answers together, because with combinations, everything gets multiplied. Okay, so it's almost like you got to go back to the license plate example, and you're doing one of these formulas. All right, so probability, it's a little tricky. Some of you guys are feeling pretty good about this stuff, though, so I'm happy. You can start looking at the homework if you want. We'll have time in class tomorrow, so you don't have to start tonight if you don't want to. But the homework is on there. There's the homework packet. And you can start playing around with some of the permutations and combinations. So let me show you where those are located if you're curious. Go to modules, and then scroll down these till we get to main homework packet right here. Where you at? There you go. And so you can kind of look at, we did the counting principles homework today. Just play with them, see what you get. We're going to be in class tomorrow. There's 2 worksheets on these. I'm happy to go over any of these with you guys in class tomorrow's work, because learning and asking questions and doing the examples is about the only way I can guarantee you're going to have success with probability. Otherwise, if you're just watching and you're doing it last minute the night before the test, copying the answer key, I mean, you're going to get 100, yes, on the homework, but the test is going to be mean to you. So practice these, make mistakes, then go check your answer key. This is really the unit where you want to start not using it to write your answers, especially if you don't have to write a bunch of stuff. You're just doing the formulas. Have a good rest of your day, people in class and Zoom. Like I said, tomorrow we'll go over any questions you guys have as far as the homework. And we'll see you then.